Okay, so that's it for the lesson number 2, where we discussed about the threat actors, the threat actor types, the TTPs, the vulnerabilities, threat and risks. Okay, the different types of threat actors. Okay, like black hat, white hat, gray hat, intentional, unintentional, your insider threats, external threats, insider threats in the external threat actors and all. Right? We discussed about the threat researchers, threat intelligence platforms, uh, and the threat data feeds, and then some of the standards over there for the threat data feeds, right? With the AI and machine learning with the predictive analysis. All right. That's the end of the module number 2. Let's start the lesson number 3. Okay. The lesson number 3 will be talking about the performing of security assessment. Okay. And here, the first topic is the organizational security and network reconnaissance tools. Then we'll be discussing about the security concerns with the vulnerability types, then vulnerability scanning techniques, and then the penetration testing concepts. Okay, so let's go and discuss about the tools to assess the organizational security. Okay, so I hope you all are familiar with these things: ipconfig, fconfig, IP ping, R. And you need to look for the IP address of your machine. You use ipconfig when it is a Windows machine. If it is a Linux machine, you can go for ifconfig or IP space -a. It will give you the local IP configuration, whatever you want from your machine, what IP address, what MAC address, and all. Right? Ping, test the connectivity with the host. Okay, it probes the host on a particular IP address or the host name using the ICMP protocol. Okay, ICMP stands for Internet Control Message Protocol. Then you have the ARP, that is Address Resolution Protocol. Okay, it when you run the ARP space -a in your Windows machine, it will give you the ARP cache. ARP cache basically shows all the MAC addresses of the interface associated with each IP address the local host has communicated with recently. Okay, and this is useful if you are investigating a suspected spoofing attack. Okay, like if you're suspecting a man in the middle attack, you can go for this and have a look that, okay, if there is one MAC address for two different IP address or two MAC address for two different MAC address for one IP address. Okay. Then you have the route and trace route. Okay. Route basically will give you the local routing table of the machine. Okay, whether it is Windows or Linux, mostly it works on Linux. Okay, you type route space -n, it'll give you the routing table over there. Most end systems use a default route to forward all the traffic for the remote network via gateway router. Okay, and if the host is not a router, additional entries in the routing table could be the suspicious one. Okay, then there are trace RT, trace route, and path ping. Okay, and MTR. These are the 4 commands. Okay, trace RT runs on Windows, trace route runs on Linux, path ping, it's the Windows tool, and MTR is the Linux based tool. Okay, trace RT or trace route are both the similar kind of thing. They basically use ICMP, okay, probes to report the round trip time for the hops between the local host and the host on a remote network. Like if you go for traceRT space www.google.com, it will give you the list of number of it will give you the list of hops or the routers between you and the Google's machine. Okay, between your machine and the Google's machine. Same goes with the trace route in Linux. Okay, so what happens basically in the trace route and the traceRT? Okay, it will send one packet, the first packet, first ICMP probe with the TTL1, time to live 1. Okay, so in the second one, okay, for example, this is your machine and this is the Google server. Okay, you send the request. First machine, the TTL, what exactly is your understanding on TTL, time to live?
It's the amount of hops a packet can make before it gets terminated, correct?
Sorry? Come again, please.
It's the amount of hops a packet can make before it's terminated.
Exactly, exactly. So in trace route or the traceRT, the TTL value is set to 1. Okay, so it will only reach the first machine, first hop, okay, whichever is there in the network. Okay, and then after that, the packet will be terminated or vanished. So one error will be generated by ICMP saying ICMP TTL limit exceeded. Okay, from this machine, from this machine. So in response, we will get the IP address of this machine. Got it? Second packet that will leave this machine, your machine, will be TTL value 2. Will be with the TTL value number 2. The third will be number 3. The fourth will be number 4. The fifth will be number 5, and so on till 30. The maximum default limit of the TTL values is 30 in traceroute or traceRT. Okay, set by IEEE, RFC, whatever you call it, that it should be the system, the machine, that whatever you're trying to get, okay, it should be within these 30 hops. Okay, that have to make sure, that's basically the standard. It have to make sure that it should be between these 30. Okay, less than 30 systems, basically 30 hops, basically. Okay, so this is how this trace route or traceRT works. Okay, TTL value 1, ICMP packet, ICMP TTL exceeded, error will be generated from this IP address. Second, this will generate the IP. This will generate the same error. This will also generate the same error. This will also generate the same error. This will also generate the same error until and unless the specific IP address is reached. Okay, is found. The errors will be there. So in that manner, you will come to know about the exact path between your machine and the XYZ server. Got it? We need to test the path to a remote host. That is where we use the traceRT or traceroute. Okay. Path ping that measures the latency, okay, and the packet loss along the route over a long measuring period. Okay, and the same work will be done by MTR. Okay, it will check for the latency, that how much time it took for the packet to reach its destination. Okay, clear? Question or confusion? I hope not, right? Then there are IP scanners, and the Nmap is the name. Whenever you go for IP scanning, okay, there's only one name that people will talk about, that is Nmap. Okay, now scanning a network using the tools like ping is a time consuming and non-stealthy and does not return the detailed results. Okay. Most topology discovery is performed using a dedicated IP scanner tool. Okay, this IP scanner tool performs the host discovery and identifies how the hosts are connected together in an internetwork. Okay, so Nmap is there. Okay, it basically utilizes the SNMP mostly. Okay, when it comes to Microsoft system. Okay, simple network management protocol. Okay, Nmap is there. That is one of the most popular open source IP scanner. Okay, there are different methods of this particular tool. Okay, used by this particular tool to run the scans. Okay, to discover the hosts that are alive in the network, to uh, operate stealthily and serve to defeat security mechanisms like the firewalls or the intrusion detection systems. Okay, and this tool is open source, works on Windows, Mac, and Linux, all of them. Okay, command line version is Nmap, and graphical user interface is Zenmap of it. Okay, and you can see the syntax over here. This one, Nmap space 10.1.0.0/24. That's basically the host name, the IP address range basically. Okay, this command, this IP address, this Nmap basically will go and try to ping. Okay, try to get the port numbers that are open, try to get the open ports in all the 255 IP address starting from 10.0.1.1 to 10.1.0.255. Okay, so in all the machines, all the TCP ports that are open will be listed over here, just like the output as you can see in this screen. Okay, this is how we do the port scanning in using Nmap basically. Okay, then you have the service discovery and Nmap. Okay, now using Nmap and the switches with the Nmap, okay, to perform the service discovery. Okay, now in here, in this particular command, you have the service over here, right? Without any switch. Without any switch. There is no switch used by the Nmap. Okay, the service is listed like 53, domain service, 80,